All right, guys, I'm going to show you how to finish up the modified Atwood lab. So just a quick reminder of what we did. We had our cart here on our frictionless track. We had some washers on here that we then removed one at a time and put over here to provide the necessary force to accelerate our system. So one thing to note is that because we took our washers from the cart and then added them here, the mass of our system did not change. So the mass of the system is constant, and that's an important thing to note. So a couple things. We measured out a set distance that the cart accelerated through, and we recorded the time that it took to accelerate from one point to the next. And for most of you, that was 0.5 meters. Okay, so to calculate our average velocity, we did the distance divided by time, and our distance was 0.5 meters, which we then divided by our time that you recorded. Okay, so that gave us our average velocity. Then we were going to take that and find our final velocity. So recall that our average velocity is our initial velocity plus our final velocity divided by 2. But because our initial velocity is 0, we end up with average velocity is final velocity divided by 2. And if we manipulate that formula, we come up with our final velocity is our average velocity times 2. Okay. And we found our final velocity, so we could plug that into our formula for acceleration. So acceleration is our final velocity minus our initial velocity divided by our time. Again, since our initial velocity is 0, it ends up being final velocity divided by time. So our acceleration is our final velocity divided by time. And for the last thing we have to calculate, it's our net force. And the net force is going to be the weight of the washers that we put on our hanger over here. Okay, so as we increased our weight here, we had a greater and greater net force, which was then going to be used to accelerate our system. Okay, so we found our average velocity, our final velocity, our acceleration, and our net force. And so I'm going to show you how to plug this into Sheets, and you have Sheets do the work for you in making those calculations and your graph. So I put in some fake numbers over here. So the 0.5 meters going down for everybody, I used numbers that are very close to the actual masses that you should have, just so you could see what you should have about for your mass of your washers. Again, your number should get larger as you go down because this is for 1 washer, 2 washers, 3 washers, 4 washers, and 5 washers. And then the times should decrease as the cart is going to have a greater and greater acceleration. So then I just added in these 2 columns, and you don't have to make it nice and pretty like this. I just type this in, and so I want to find my average speed. So I'm going to click on this cell right here, and again, our average speed is going to be our distance divided by time. So to have the formula, I'm going to type equals. I'm going to click on the distance, which is 0.5 meters. I'm going to click divided by, and then I'm going to click on time, and I'm going to hit enter. And it gives me 0.22. Now, I already went through and decreased my decimal places. So again, if you get a whole bunch of decimals over here, you can come up to this this function right here and just click on this to decrease the number of decimals. Once I have my 0.22 here, I'm going to click back on that cell. I get that little box right there that I can go over. And when I hover over it, it gives me the cross that I can then click and pull down, and it auto fills it for me. Okay, so then to get my final speed, again, I'm going to click on this cell right here. I'm going to hit equals, and the final speed again is my average speed. So I'm going to click on that cell, times, so shift 8 gives me that star symbol. That's my multiplication. And then times 2. So I'm going to enter 2 and hit enter. And then again, I'm going to come back up here, click on the cell, and go to that box, pull it down, and it auto-fills it for me. Once again, if you have a whole bunch of decimals in here, you can just click on this right over here and reduce the number of decimals. Okay. So I did all of that so I could get this right here. So my acceleration of my system, I'm going to click on that cell, and I'm going to click on equals. And again, my acceleration is my final speed right here. So I click on that, divided by and then my time, which is right here. And then I'm going to hit enter. And then again, I'm going to click on this cell and pull it down. And I have my accelerations now. And then for my net force again is the weight of my washers. So to do weight, it's going to be mass times gravity. So I'm going to hit equals. And the mass, I'm going to come all the way over here, click on the mass of one washer, and then I'm going to multiply that. So shift 8 times gravity, which I'm going to use 9.8 to be a little bit more precise. And then I'm going to hit enter. I get my number, click on that cell, and again, highlight it and pull it down. And now I have my net forces. So it asks you to make a graph of net force versus acceleration. So I'm going to highlight all of this. I'm going to, and I can't, like, you can't see the chart up here, so I'm going to click on these 3 dots for more, and there is the insert chart tab. So I'm going to click on that. And mine automatically defaulted to a scatter chart, which you should be using. Please do not use a line graph. Definitely don't use a bar graph. Under setup, if yours defaulted to a bar graph, which it often will, just scroll down until you see scatter and click on that. And then once you've got that there, then you're going to come to customize, come down over here to series, scroll down until you see your trend line. Even though mine does not match this data for linear, yours should be linear. And then so once you clicked on the trend line, it defaults to linear. And then under label, you want to use equation. And click on that R squared value. My R squared is very poor, 0.797. Yours should be much closer to 1. And then the use equation, the reason I clicked on that is if I come right there, I can see that the slope of my line is 0.193. Now recall that a net force versus acceleration graph, the slope of that graph is going to be the mass of your system. So this is the mass, and so my mass would be 0.193. You should have a much different mass for your system than 0.193. Okay, and that's where we're going to end. And then just use your graph to answer the rest of the questions, and have a wonderful rest of your day. Please submit this today and then move on to the 6.1 and 6.3 sheets that I have put in for today. Have a great day.